Hey everyone, and welcome back for another deep dive. This time, we're taking a look at something that's both fascinating and a little bit scary.
Yeah.
Black holes.
Yeah, black holes.
Um, I don't know about you, but I feel like every time I turn around, there's a new article or a study or, even just some crazy theory
Right.
about black holes, and it can be hard to keep it all straight.
Absolutely.
So that's what we're doing today. We're going to break down what we know about these mysterious objects, how they
Yes.
form, what happens if you get too close,
hmm
and even how scientists are able to spy them.
Yeah, it's pretty amazing that something that's essentially invisible
Yeah,
can be so powerful and have such a huge impact on the universe around it.
that's a great point. I mean, we can't actually see a black hole directly, but we can definitely see the effects that they have
Right.
on their surroundings.
And that's actually how we know they exist.
Right.
We see stars swirling around seemingly empty space or galaxies being distorted,
Yeah.
and we can infer that there must be a black hole there.
It's like trying to find a ghost. You can't see the ghost itself, but you can see the way it interacts with the world around it.
Exactly. So, ready to dive into the heart of a black hole.
I am. Let's do it.
All right, let's start with the basics. How do these cosmic behemoths even form in the first place?
Well, there are actually a couple of ways. The most common way is through the death of a star, a very massive star.
Okay.
Now, when a star runs out of fuel, it can no longer support itself against its own gravity,
Right.
and so it collapses in on itself.
Okay.
This collapse can trigger a supernova, a massive explosion that blasts away the outer layers of the star.
Wow.
But sometimes if the core of the star is massive enough, it keeps collapsing and collapsing until it forms a black hole.
I mean, that's pretty incredible. It's like the ultimate cosmic recycling program, right?
Yeah, you could say that. Death of a star leads to the birth of a black hole.
So that's one way. What about the other way? Yes. The other way is a little bit more mysterious. It involves these supermassive black holes that we find at the centers of galaxies.
Yeah.
Now, these black holes are millions or even billions of times more massive than our sun.
Whoa.
We're not exactly sure how they form, but we think it involves a combination of things like smaller black holes merging together
Okay.
and gas and dust falling into the black hole
Yeah.
over billions of years.
So like a cosmic vacuum cleaner?
Oh, yeah, you could say that.
Okay, so we've got these two main types of black holes, stellar mass and supermassive. But what exactly is a black hole? I mean, we keep saying the word, but what's going on inside of one of these things?
Well, imagine a region of space where gravity is so strong that nothing, not even light,
Oh.
can escape. That's essentially what a black hole is.
So if you were to fall into a black hole, there would be no way to get out.
Nope. Once you cross a certain point called the event horizon,
Mm-hmm.
you're doomed. You'd be pulled in towards the center of the black hole where all the matter is compressed into an infinitely small point called a singularity.
A singularity. What's that like?
Well, that's where things get really weird. The singularity is a place where our current laws of physics break down. We don't really know what happens there.
So it's like a cosmic mystery zone?
Exactly. It's
Yeah.
a place where space and time, as we know them, cease to exist.
So we've got this event horizon, this point of no return, and then this singularity at the center where all the matter is crushed into this infinitely small point.
That's the basic picture, yeah.
Okay, so it's invisible and incredibly dense and it warps space and time. But how do we even know these things exist?
That's a great question. And it's something that puzzled scientists for a long time. Remember, black holes don't emit light. They're black. So we can't see them directly.
Right. So how do we know they're there?
Well, we have to rely on indirect evidence. One way is by observing the motions of stars and gas near a suspected black hole. If you see stars swirling around a seemingly empty point in space at incredibly high speeds, that's a pretty good indication that there's a black hole lurking there.
Okay, so it's like watching a cosmic dance with the black hole leading the way.
Exactly. Another way we could detect black holes is through their gravitational effects on light. Remember how we said that black holes warp space and time? Well, that warping can actually bend the path of light that passes near them. So if we see light from a distant star or galaxy being distorted in a particular way, that can tell us that there's a black hole in the foreground.
So it's like a cosmic funhouse mirror.
Yeah, kind of like that. And then there's gravitational waves.
Gravitational waves.
Yeah. Remember how we said that massive objects like black holes warp space and time? Well, when these objects accelerate or collide, they create ripples in space-time that propagate outward at the speed of light. We call these ripples gravitational waves.
And we can actually detect these waves.
We can. Thanks to some incredibly sensitive instruments like LIGO and Virgo, we're now able to pick up these subtle distortions in spacetime caused by events like black hole mergers.
Wow, so we've gone from theorizing about black holes to actually detecting the ripples they create in the fabric of space-time.
It's pretty amazing, isn't it?
It is. It's like we've opened up a whole new window into the universe.
Exactly. And it's a window that's giving us incredible insights into the nature of black holes and the workings of gravity itself.
So we've covered how black holes form, what they're like, and how we detect them. But what about their cultural impact? I mean, black holes have captured our imaginations for decades, showing up in movies, books, video games, you name it.
You're right. Black holes have become these iconic symbols of mystery and power. And the way they've been portrayed in popular culture has evolved over time, reflecting our growing understanding of these fascinating objects.
Okay, so let's talk about that evolution. Early depictions of black holes in science fiction often portrayed them as these menacing, all-consuming monsters, right?
Yeah, they were often seen as these cosmic whirlpools of doom, sucking up everything in their path.
Like the ultimate cosmic vacuum cleaner.
Huh, exactly. But as our scientific understanding of black holes has grown, so too has their portrayal in fiction.
So how has that portrayal changed?
Well, we've started to see more nuanced and sophisticated depictions of black holes. They're still powerful and mysterious, but they're not always portrayed as purely destructive forces anymore.
So they're not just cosmic villains anymore.
Right. Some stories now explore the idea of black holes as potential gateways to other dimensions or even time travel portals.
Okay, so they're not just about destruction anymore, they're about possibilities.
Exactly. And some stories even use black holes to explore philosophical questions about the nature of reality and the limits of human knowledge.
It's like black holes are a canvas for our deepest fears and our wildest dreams about the universe.
I like that. A canvas for our cosmic imagination.
That's a perfect way to put it. And speaking of cosmic imagination, have you ever wondered what it would be like to actually see a black hole?
Of course. I mean, we've talked about detecting them indirectly through their effects on their surroundings, but actually seeing one directly, that would be mind-blowing.
Well, get this. Back in 2019, the Event Horizon Telescope, a global network of radio telescopes, achieved something incredible. They captured the first ever image of a black hole's shadow.
Wait, seriously, we have an actual picture of a black hole.
We do. It's a bit blurry, but it clearly shows the silhouette of a supermassive black hole at the center of the galaxy M87.
That's incredible. It's like finally seeing a ghost after years of hearing rumors and whispers.
Exactly. And it's a testament to the ingenuity and collaboration of scientists from around the world who made this groundbreaking observation possible.
It's a reminder that even in the face of these mind-boggling cosmic phenomena, we humans are capable of achieving incredible things when we work together.
That's a great point. And that makes you wonder what other incredible discoveries await us out there in the vast expanse of the universe.
Who knows what wonders we'll uncover next, but I have a feeling that black holes will continue to play a starring role in our cosmic explorations for many years to come.
I agree. They're just too fascinating and too mysterious to ignore. And with every new discovery, we get a little closer to unraveling the secrets they hold.
Absolutely.
Okay, so we're back and ready to dive even deeper into the world of black holes.
Deeper, I thought we were already pretty deep.
Well, hold on to your hats because things are about to get even weirder.
Bring it on. I'm all ears.
So we talked about two main types of black holes, right? Stellar mass and supermassive.
Yep, those are the big ones.
But it turns out there might be a middle child in the black hole family.
Oh, you mean intermediate mass black holes?
Those are the ones. Tell us more.
Well, as you might guess, they fall somewhere between stellar mass and supermassive black holes in terms of size. Think hundreds to tens of thousands of times the mass of our sun.
Okay, so not quite the heavyweights, but definitely not lightweights either.
Right. And the interesting thing is, we're not entirely sure how they form.
Oh, another black hole mystery.
Seems like there are always more mysteries when it comes to black holes.
That's what makes them so fascinating. So what are some of the theories about how these intermediate mass black holes form?
One idea is that they might form from the mergers of smaller black holes in dense stellar environments. Like imagine a bunch of stellar mass black holes bumping into each other and combining over time.
Kind of like a cosmic demolition derby.
Huh. Yeah, something like that. Another possibility is that they formed directly from the collapse of massive gas clouds in the early universe. So instead of going through the whole star phase, they just skipped right to black holehood.
Like an express lane to becoming a black hole?
Exactly. But whichever way they formed, these intermediate mass black holes are out there lurking in the shadows, and they're helping us piece together the bigger picture of black hole evolution.
It's like filling in the gaps in the black hole family photo album.
Exactly. Now, speaking of the early universe, there's another type of black hole we should mention, primordial black holes.
Primordial black holes, that sounds intense.
They are pretty intense. The theory is that these black holes formed in the very early universe, shortly after the Big Bang, when conditions were incredibly extreme.
So they're like the ancient elders of the black hole world.
You could say that, and the thing about primordial black holes is that they could come in a wide range of sizes, from tiny specks smaller than an atom to colossal giants even larger than supermassive black holes.
Wait, smaller than an atom? Seriously?
Yep. It sounds crazy, but it's possible, according to some theories. Of course, we haven't actually detected any primordial black holes yet.
So they're still in the realm of hypothesis.
For now, yes. But if we did find them, it'll be huge. It would tell us so much about the early universe and the conditions that existed back then.
It's like these primordial black holes are holding on to secrets from the very beginning of time.
Exactly. And who knows what those secrets might reveal.
Okay, so we've got these different types of black holes, but there's still one big mystery we haven't fully tackled yet. The information paradox.
Ah, yes. The paradox that just won't go away.
It's a real head scratcher. Remind us again what the issue is.
Well, it all boils down to this. What happens to all the information that falls into a black hole? Like, if a star gets swallowed up by a black hole, where does all the information about that star go?
Right, does it just disappear?
According to classical physics, that's exactly what happens. Once something crosses the event horizon, it's gone, and all the information about it is lost forever.
But that doesn't sound right, does it? I mean, isn't there a fundamental law of physics that says information can't be destroyed?
That's the problem. Quantum mechanics, which governs the behavior of particles at the subatomic level, says that information can't be destroyed. It can be transformed, but not destroyed. So we have this conflict between classical physics and quantum mechanics.
So what's the solution? How do we reconcile these two seemingly contradictory ideas?
That's the million-dollar question. And it's a question that has puzzled physicists for decades. There are a lot of different theories out there.
Like what?
Well, some physicists believe that the information might be encoded on the surface of the event horizon, like a kind of holographic projection.
So it's like the information is plastered onto the black hole's outer shell?
In a way, yes. Others suggest that the information might leak back out through some subtle quantum effects, like Hawking radiation, although that's still debated.
So we're still searching for the missing information.
Exactly. And the search is leading us to some really mind-bending ideas about the nature of information, the structure of space-time, and maybe even the very fabric of reality itself.
This is getting pretty deep. I think I need a moment to process all of this.
Me too. It's a lot to wrap your head around. But that's what makes black holes so fascinating, right? They challenge us to think beyond our current understanding of the universe and to explore the limits of what we know.
Okay, so here we are, back for the final part of our black hole deep dive.
It's gone by fast, hasn't it?
I know, right? It feels like we've just scratched the surface of these incredible objects.
Yeah, and there's still so much we don't know.
But even with all that we've learned, I think it's safe to say that black holes have earned their reputation as some of the most fascinating and mysterious things in the universe.
Definitely. They really challenge our understanding of physics and reality.
Speaking of challenges, remember that information paradox we were talking about?
Yeah, the one where information seems to disappear inside a black hole.
Right, and that doesn't really jive with our understanding of quantum mechanics, which says that information can't be destroyed.
Exactly. It's a major puzzle that physicists are still trying to solve.
So what are some of the ideas out there? How could information possibly survive a trip into a black hole?
Well, one idea is that the information doesn't actually get destroyed. It just gets scrambled up and spread out across the event horizon.
So kind of like a cosmic blender?
Yeah, something like that. Another idea is that the information might be encoded in the Hawking radiation that escapes from the black hole.
But didn't we say that Hawking radiation is random? How could it carry information?
That's the tricky part. Some physicists believe that there might be subtle correlations within the Hawking radiation that we haven't detected yet.
So it's like a cosmic code that we need to crack.
Exactly, and cracking that code could revolutionize our understanding of black holes and the universe itself.
It's incredible to think that something as seemingly destructive as a black hole could actually hold the key to unlocking some of the biggest mysteries in physics.
I know, right? Black holes are full of surprises.
So, as we wrap up our deep dive, I wanted to come back to something you said earlier about black holes being a testing ground for our understanding of physics.
Yeah, they're like these extreme laboratories where we can push the boundaries of what we know.
Can you give us an example of how black holes are helping us to refine our theories?
Sure, take Einstein's theory of general relativity, for example.
Hmm.
It's been incredibly successful at explaining the behavior of gravity on a large scale, but black holes are so extreme that they really put the theory to the
And
test.
so far, general relativity has held up.
So far, so good. But we're always looking for those tiny deviations, those little discrepancies that might point us toward a new and even more comprehensive theory of gravity.
It's like those black holes are daring us to figure them out.
Yeah. And with every new observation and every new discovery, we get a little bit closer to understanding these incredible objects.
Well, it's definitely been an amazing journey exploring the world of black holes with you.
The pleasure was all mine.
For anyone listening who wants to learn more, where's a good place to start?
Hmm. Well, there are some great books and articles out there, but honestly, I think one of the best things you can do is just look up at the night sky and let your imagination run wild.
That's great advice. After all, who knows what other wonders are out there waiting to be discovered?
Exactly. And maybe someday we'll even be able to travel to a black hole and see it for ourselves.
Now that would be the ultimate deep dive. Thanks for joining us, everyone, and until next time, keep exploring the universe.